In problems 9 and 10, we're asked to solve the triangle, which means to find all of the missing side lengths as well as angle measures. So a good first step is to just go to your picture and fill in all of the numbers that we do know. For instance, we know that angle B is 40 degrees. We also know that side A is 6. That means the side opposite angle A is 6. The side opposite angle B is B, and the hypotenuse is C. Well, very quickly we can see that angle C has to be 90 degrees because it's given with a nice right angle symbol. And all of our angles have to add up to 180, so 90 plus 40 plus whatever A is has to equal 180. That's 130. I'll subtract 130 from each side. And A is obviously 50, so angle A is 50 degrees. Now, to find the missing side lengths, first I'm going to try and find side B. And B is opposite angle B. And 6 would be adjacent to B. Opposite and adjacent means I'm talking about tangent. The tangent of angle B is going to equal opposite over adjacent. The angle was 40 degrees. The opposite is B, and the adjacent side is 6. So that means B multiplying by 6 on both sides is going to equal 6 tangent of 40. If our calculator is still in degree mode, we can just type it in. And you'll get 5.034. So go 3 decimal places, 5.034. And now we need to calculate C, which we could do using Pythagorean Theorem. With that number already in our calculator, we could think of that side as B squared plus A squared, which is 6, is equal to C squared. We are trying to solve for C, so C is going to equal the square root of B squared plus 36. Now, the reason I mentioned the calculator thing is that if I have that big long decimal already sitting in my calculator, then all I have to type in is square root of answer squared plus 36. Make sure that's all in parentheses. And letting the calculator do all the work, we find out that side C is 7.832. In problem 10, we're going to solve the triangle again, but this time the angles are measured in radians. Still, our process is going to be the same. Identify first what we know, and that is that angle B is pi over 6 and side B is 5. We still need to find angles A and C as well as sides A and C. Obviously, angle C is our right angle, and in radians, that means it's pi over 2. To find the third angle, we need to add all of our angles together, pi over 2 plus pi over 6 plus angle A, to end up with 180 degrees. In radians, that's pi. First, I want to simplify the sum of these two angles, so I need common denominators. And pi over 2 is 3 pi over 6 plus 1 pi over 6. So I'm going to subtract 4 pi over 6 from each side. And that'll leave us with A being pi, or 6 pi over 6, minus 4 pi over 6, which is 2 pi over 6, or pi over 3. So angle A is pi over 3. Now when it comes to the missing sides, we can again use tangent of angle B to help us figure it out. Tangent of the pi over 6 would be the opposite over adjacent, in this case A. So I'll multiply both sides by A to get rid of the fraction. A tangent of pi over 6 is 5. Now I'll divide both sides by tangent to get A by itself. Now before you just start typing everything into your calculator, you need to recognize that we are dealing with radians and we need to change the mode. So go into the mode menu and scroll down to radians and select that. Then we can type everything in just as it looks. That is 5 divided by tangent of pi over 6 in parentheses. Don't forget to put that pi over 6 in parentheses, otherwise your calculator will try and find the tangent of pi and divide that answer by 6. Anyway, when it's all said and done, you should end up with 8.660 as being side A. Last thing, we can find the third side using Pythagorean Theorem, because Pythagorean Theorem would say a squared plus b squared is equal to c squared. A is at 8.660. It should still be sitting in your calculator. So to find c, we have to take the square root of both sides. So we'll type in the square root of answer squared plus 25 and finish it up with the extra set of parentheses there. And you get a very nice number of 10, which we should have saw that coming, knowing that pi over 6 is 30 degrees and pi over 3 is 60 degrees. So this is a 30, 60, 90 triangle, making the hypotenuse twice as long as the short side.